Hello and welcome back. Today I have a clamp multimeter and it's from the brand GVDA, and they sent this for free for me to show it to you. And it is a clamp multimeter, and usually the cheaper clamp multimeters only do AC, and this one can also do DC, and it can even do Inrush. So interesting. Here we have the box. Looks nice, I think. Same box for the three models. This one is the GD166B, and it is the one with most options. So let's have a look at the meter themselves. Yeah, I like this when they do this. They give you a nice thing to put. Manual, English, no. Ropes. Okay, flexible, but not too flexible. Looks proper. Oh, look, it even has temperature. Cool. You see that more and more on the multimeters nowadays. Well, you can see it's brand new. Well, it looks proper. Feels okay. Ooh, good spring. It has a non-voltage detection as well. You see that also more and more. And wow, the display. Let me see. Okay. It did not come with batteries. I think it goes 3 times AAA. So let's do that. Okay. Oh, the screw already falls out, so it's not locked. Huh. It already wants to do things. Okay, here is a light. It's the hold, but it is also, look at that, a flashlight. The display looks nice. It reminds me a little bit of those Kaiwitz full screen meters, or the Eneng. They have this automatic mode, so that is pretty nice. We have now amps, voltage, ohms, so you can override also the automatic mode, even as a diode test. Interesting. Millivolts, capacitors even, non-contact voltage. Yeah, working. Cool. Makes sounds. Okay, works. Seems very sensitive, even when that works pretty good. When we switch it on, it does some sort of calibrating. There is a constant temperature measurement also, in no matter what mode. It was now in auto, now it's manual. Manual amps DC, but if I do select, I can go to AC, or I can do Inrush current, and now it's back to DC. Temperature stays there, so it has an internal temperature sensor. Voltage, DC, switch it over to AC, and it also shows a frequency in AC. Interesting. Let's try. And back to DC. We have the ohms measurement, also temperature there. No extra mode there. We have here the continuity. No extra mode there. Temperature is still there. Diode mode. Millivolts. Also millivolts AC. Okay, interesting. frequency, and I see a percentage, so probably also duty cycle. Okay, capacitors, temperature, both temperatures. It's using now the internal sensor. It's a bit weird, it says here 23 because in the other mode it said 21. Here it's 21.8. But maybe it's because there is no sensor connected. That's weird. And then it should just say overrange or something. Ah, now it's correct. Now it's just, maybe it needs to be switched on and off with the sensor on it, that it can calibrate the sensor during startup. $22.5. Okay, that makes more sense now. Now the internal and the external sensor seem to agree. Okay, it's 6000 count, so I would think that the millivolt then goes up to 6 volt. So we should be able to see, if I put this in AC, put it on, that we probably can see in the millivolt setting also the duty cycle and everything. So let me see. It knows it's AC. It is now in the normal voltage. So it is true RMS, because otherwise I should have seen here 5.5 volts and it doesn't. So that's actually good. Can I go to, if I just go now to the millivolt, or is it up to 0.6? No, it's 0.6, okay. What about the frequency here in the duty cycle? Yeah, 100 Hz, 50%. And if I go to 10K, yeah, 10K, 50%. That is correct. Let me go to DC voltage. Exactly 5 volts this should be, yeah, 4997. Oh yeah. Okay, current. Can we do also very low currents? Yeah. 1 milliamp. Does it see 1 milliamp? No, okay. That is not enough. Let's do some ohms. How is my ohms measurement? I think I can even zero it. No, it's not needed, it's already zero. 100. It's not that fast, but the value is good. 1K is usually spot on. Well, 1 digit extra. 10K. 100K. Perfect. What about capacitance? Yeah. Yeah. This is a little bit high. Yes. I have also a diode, so let's do that one. Yeah, works. What is the voltage? It's doing a little bit over 3 volts. I don't know, usually the manual says 2.7, but this one is a little bit higher. I quickly checked the manual and the diode is indeed 3 volts, but we saw on our meter, if it is, well, if it's open, then it was 3.2 volts, so that is correct. I was thinking that the lower currents you can do also in the terminals in the bottom, but that is not the case. You can only do current through the clamp, so let's play with that. So I have here a big power supply, it can do up to 40 amps. I have here my electronic load, and how much amps can that do? Or also 40 amps, and it can do a total of 400 watts. So if I want to go to 40 amps, well, it's a bit questionable for my wires. I cannot go above 10 volts because then I hit my limit. So let's first put 1 amp. They also say that that is kind of this one, if this is not 0 that we have now, then we have a 0 button to 0 it out. And now it's zeroed out. And now it starts to go again. Let's just keep it in the default. I want 1 amp. Oh shit. 1 amp on. Yeah. Okay. Oh, it still thinks it is on 4. That's a little bit of a bug with this meter. Now it's correct. Now let's see. Yeah, it does. Say it's 1 amp. Let me just leave it like this and increase the current. 2 amps. Correct. Let's do it on the side. It is 2 amps. Go higher. 3, 4, 5. $20 amps. Well, now my cable probably goes soft, but it is not that bad. DC amps we have here with the clamp multimeter. Well, we saw that the current was not necessarily spot on, but don't forget it's a clamp multimeter and it's used to do very high currents. And this one can go up to 600 amps. So if you have then half an amp extra on 600, it doesn't matter too much. Yes, it says here it's on DC, it's like 2.5% off, plus 5 digits. I think we were well within that. On AC it's a little bit different. In the first scale up to 60 amps, they say it's about 2.5% plus 5 digits. But if you go on 600 amps on AC, and it's like 3% plus 10 digit. And if you check the Inrush, which is interesting because a lot of these clamps don't have that, it is 5% plus 10 digits. But it's interesting to see, so I don't know, I need to start a vacuum cleaner or just to see if it goes or not. I have a little setup. Here we have the electrical parameter tester. This one is on the primary side here of the power supply, so we're actually measuring the current that the power supply takes. This is the secondary side, and I have here the electronic load again. So we have 240 volts on one side. Yeah, the sun is shining, so all the neighbors are producing a lot of energy. And it is taking 2 watts already. But let's put it on. 4 amps. So we should have 5 volts, 4 amps on this side. We have, that means 19 watts. Here we have 30 watts. How many amps? 0.2 almost. So let's see if we measure 0.2. Power on. Go to amps. Go to AC. Only one wire. 0.2, 0.19, 0.2. Okay, we can do maybe a little bit more. Amps, it's also the maximum of this one, and it's 0.4, and indeed we have 0.4 on the meter. Let's do some AC current. The secondary side is doing nothing. I have my big vacuum cleaner. It's to the lowest setting, and well, the clamp is still in between the system. So power it up. It's 4.4, here is 4.5, it's reasonable. Let me put some more power. What is maybe more interesting, the current works, is to do the inrush, because it's an electrical motor, so it will have a high inrush current. So if I put it now to inrush and I start the motor, it says that the inrush current was 12, while we saw when it was in continuity use it was about 4. So let's do it to the higher setting. What will the inrush then be? Hopefully my fuse don't blow. Okay, here we go. Now it says the inrush is about 28 amps. Here we have it zoomed in. It says 2799, so 28 amps. And it has an automatic hold function because I didn't do anything to do that. Yeah, I can't really check that because I don't have any other meters that do inrush. There is also another function I didn't show, the non-contact voltage we already checked, but you can also probe only with one active wire. It's on the same setting. You only put it in a positive wire, and then, yeah, of course, it will detect something. And then you should be able to, yeah, it's a bit difficult to hold, but then, so this is the active, and it is then the low. And you can do that by just one wire. So all in all, I think it's a proper meter, especially for its price. For this low price, it's probably around 35, depending on your live. Maybe if you buy it in the US, it's even only $30. We pay around 35 here. It has not only AC, it has also DC current, which is very nice. You don't see that too much on the lower ends. And the inrush. This is really the first time, my first clamp multimeter I have here that actually has inrush current. And I think with the vacuum cleaner was a nice test. And It is just a peak that an electromotor has when it starts. So thank you for watching, and hope to see you next time.